All right, students, so today I'm going to be talking about the quadrilateral family tree. As you can see here, we have spent a good amount of time these last few days talking about parallelograms here. And as I mentioned, there are three really subgroups. There are three subfamilies within that entire quadrilateral family tree. You have parallelograms, trapezoids, and kites. And so we talked a lot about parallelograms, and so we're going to be now looking at these four here, and really more specifically, the specific types of parallelograms, that being rhombus, rectangle, and square. So your task for today is going to be starting to comparing and contrast the properties of rhombus, rectangle, and square. You know, what makes them similar, what makes them different. And so a big thing to remember is that all of them possess the properties of the parallelogram because they are all parallelograms. So all of these properties here, opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals bisect each other, those are all true of rhombus, rectangle, and square. They maintain those properties because they are types of parallelograms. So if you were asked to explain, how ways that you know that they're similar, that's really ideally how you do it. You say, well, a rectangle is a type of parallelogram, so we know that its opposite sides are still parallel. So what I'm really going to try to do is try to explain the differences between them and how we apply those properties. So you're going to watch this video. I'm going to have another video going over the properties worksheet, and then your goal is to finish that properties worksheet and upload it to Canvas before Monday. So let's take a look here. So we're going to now start with rectangle. So we know that it lists here that a rectangle has 4 right angles and that its diagonals are congruent. Those are really the two unique things to rectangle that are not true in rhombus, okay? So we know, for example, that a rectangle has 4 right angles or congruent angles. But again, remembering that the opposite angles are still equal, okay? We still have opposite angles that are equal here. These two are still equal. As well as consecutive angles are still supplementary. So this angle here and this angle here still add to 180 degrees. It's just that now it's more specific in that the angles are all right angles, they are congruent. We know that the diagonals are congruent to each other. And so what that means is that, to the best of my abilities here, I'm going to draw these diagonals. We know that all 4 of these parts, we used to think, okay, the diagonals are congruent, and it would look like this, right? We'd have like 2 parts that are equal and the other 2 are equal. Now, since the diagonals are the same, we know that all 4 of these parts are equal. So again, that's something unique to a rectangle. So to just quickly wrap up a few other things, I think you'll find a few other key properties of rectangles that will help you in your understanding of the properties are as follows. So it is still true in a rectangle that since it's a parallelogram, we know that this angle 1 here is congruent to angle 2. So that's something that's still true of a rectangle. And similarly, I know that this angle 3 here is congruent to this angle 4. Now, I could go and list a lot more pairs. I could similarly say this angle here, same as this one here, and so on and so forth. But I think just knowing that will help you fill in the rest of them, because I know that, okay, if this angle, I know angle 3, I can subtract from 90 to get this one and fill in the rest. A lot of subtracting from 180, 90, things like that. So that really is the specifics of rectangle that you need to know, okay? Let's come over here to rhombus. So a rhombus, we know, is a parallelogram with 4 congruent sides. That's one thing specific to a rhombus that is not true in a rectangle. Right? In a rectangle, the angles are the same. In a rhombus, the sides are the same. So that's one thing. The next thing that's fairly unique and interesting is we know that the diagonals are perpendicular. So that's something that's very unique to a rhombus, where you'll notice, like, I don't know really specifically anything about these angles over here in rectangle, but I do know that the diagonals are, since they are perpendicular, makes all of these angles here 90. So like in a rectangle, we're used to the interior angles of the shape being right angles. But here in a rhombus, it's the diagonal angles, as we will call them, that are 90. And then another thing that's also unique to a rhombus is that we're used to, for example, this angle here being congruent to this one because of alternate interior. But if you read that last property, it says the diagonals bisect the opposite angles. So now all four of these angles become congruent to each other. So now we're looking at something more along the lines of this, whereas then we know that similarly, these four angles are all the same, okay? So instead of it being something like, you know, we have this angle and this angle being the same, and then these two here being the same, instead of it being something like, you know, 1, 2, 3, and 4, instead of just saying like angle 1 is congruent to angle 4, that is true. We also know now that angle 1 is congruent to angle 2, and also really angle 3, right? I guess I could keep going and finish that out, right? Angle 1 is congruent to angle 3. And same could work for these four angles here, right, as I've shown you. So other than that, really the only other thing that you will find that's important to remember about a rhombus, this is one that kind of comes up in questions sometimes, and it revolves around the fact that if you notice, this is a right triangle, okay? So there are certain properties of specific shapes we tend to forget. Like I know this is a triangle, so the angles add up to 180. And that if this is 90, it means these two here, if 180 minus 90, also add up to 90. So getting into the specifics there, I could say like the measure of angle 1 plus the measure of angle 5 is equal to what number? What would 1 and 5 have to add up to? They'd have to add up to 90 degrees. That's one that I see that we forget a lot because we'll like know this angle and we'll be asked to find this one over here 5, and we're like, I don't know how to do that. They're not equal. And they also don't add up to 180, so again, that's what we get. So that's one that again is one of the properties of a rhombus that is forgotten often. So to summarize everything I just said, if you take a parallelogram and you add in 4 congruent right angles, you get a rectangle. Not a square, I would call it a rectangle, okay? If you take a parallelogram and you add in congruent sides, then you get a rhombus. But if you take a rhombus and a rectangle and you put them together, you get a square. So again, rhombus plus rectangle equals square. Now, when looking at the properties of a square, turns out everything in a square is either equal or bisected or equals 90 or you know, consecutive angles still add up to 180. Really, a square, again, it possesses all the properties of a parallelogram, a rhombus, a rectangle. Again, it possesses all the properties of all of them. That's really what makes it a square. So we know some basic things about a square. We know its angles are all right angles. All the sides are the same. The diagonals are equal because it is a type of rectangle, and that's a big thing to understand, is like the diagonals are not equal because it's a square. The diagonals are really equal because a square is a type of rectangle. And so I can say all 4 of these parts are equal. So one of the things I also want to dive into here is I want you to think of this, okay? So when we were looking at a lot of the similarities and differences between these shapes, let's look at what happens when you draw the diagonals. So up here with rectangle, we found this triangle was the same as this one, and that this triangle was the same as this one. Similar in rhombus, but you end up with 4 triangles that are actually the same, okay? You end up with different numbers in different locations, but it turns out all 4 of these triangles actually end up being the same. It's just the numbers are located in different spots. With a square, it gets even more specific because I want you to think of this for a second. Here, these 2 angles were not equal in a rectangle, right? Angle 1 was not congruent to angle 5. Angle 1 is congruent to angle 2, but not congruent to angle 5 there. Here in a square, it gets even more specific, as I mentioned. And this is really a key question when you're asking yourself, how do I compare these shapes? What makes them similar? What makes them different? A square gets even more specific, even more unique, to the point where it turns out that if you combine all the properties of everything we just discussed, rhombus, rectangle, and now square, you consider the fact that this angle is 90, and it is cut in half because it shares that property of a rhombus where these diagonals bisect these angles. And notice, think about like side angle side and side side side, really. All those triangle shortcuts we talked about, where it turns out all 4 of these triangles would be the same. So how do I get these angles to be the same and add up to 90? Turns out that if we take 90 and we cut it in half, we get 45 degrees, right? We take 90 and we cut it in half, we get 45 degrees. So in order for this to be a square, I know not only are those angles the same, turns out they always have to be 45 degrees. And you'll see that pop up sometimes. Sometimes you're asked, well, what do I know about, like if I'm given an expression here, like say this is 2x plus 3, I would set it equal to 45. Or if I'm given this angle, I would set it equal to 90, okay? So really that's what makes, one of the things that makes a square even more unique. So really that's the process of diving into the parallelogram part of the family tree. That's what makes a rectangle, rhombus, square unique and different. So continue on here. I'm going to look at the back of that paper and talk about the properties table real quick. So on the back of this, you have a table. And the reason why I put this on here is that some people like, I guess, it more in table form than just simply a list of properties. So what I want you to do is give this a try. And I want you to run through parallelogram, rectangle, square, rhombus, trapezoid, even isosceles, trapezoid, and kite. Maybe you can save those for later when we get to those shapes. And just start marking what properties apply to like a parallelogram. All of these are parallelograms, so they all have opposite sides parallel. We know that they all have opposite sides congruent, opposite angles congruent. There's more to it than that. That's just kind of a way to think through how to fill in this table. If a table is not your favorite and you don't think this is something that would be the best for you to use on the test, then I wouldn't worry about filling it in. But I will tell you that I do have an answer key for this table in Canvas so that you can mark all of the properties for each shape correctly. Should this be something that you feel like you like, if you like it in this format and you want to use this on the test. All right, so I'll have another video going over today's assignment, the properties worksheet there specifically. So be sure to check that out before you get started on today's assignment.